Okay, so good morning, everyone. So welcome to the online tutorial of Math2301. So week one, we study about some commands related to Matlab. And so the first question is, what do you expect from the following commands? So e to the pi over 2i. Then what do you expect? So if you remember your complex plane, yeah, then what is e over pi over 2i? Anyone remember complex number 0 plus I? Well, why it is 0 plus I? Well, because if you, so let me write down a little bit. Yeah, so pi over 2i is just like the on the complex plane you have I right here. Yeah, so it should be 0 plus I. Yeah, so and you can check. You can check in Matlab that it is the case. Yeah. So now let me start my Matlab. Yeah. So so for this type of problem, that's a good point. So can I go faster? Yes, but I have to admit people to get in the room. Sorry. So so maybe I should let Zoom just let people get in freely. Okay. So now when you say pi over 2i, right? Then it means that pi over 2 multiplied by I. Okay. So, but when you say pi over 2i, it means that so there's a difference here. So now I can share my writing whiteboard. Let me stop this. I share my whiteboard. Yeah. So so when you write e to the pi over 2i, right? Then this one by the Euler formula has to be 0 plus I, right? So it's just I, right? Because the complex plane look like this. So 0 is here and pi over 2 is here. The Euler formula, pi over 2 stop right here. But when you write e pi over 2i, okay, then the 2i come downstairs here. And this one is actually e to the minus pi over 2i, right? Okay, because 1 over I is just equal minus I, right? And then in this case, then 0 here and minus pi over 2i here should be minus I. Okay, so you can verify by Matlab. You put in Matlab and you can see that is the case. Okay, so now the next one is, so any question about this one? So then the next one is EPS. So on good, everything good. Okay, so now if you put EPS, what do you get? So anyone, when you try to put in EPS in, well, stand for the machine epsilon, very small number, but what is, how small can it be? If you put into Matlab, what do you get? So 2.2 10 to the minus 16, yeah. So how do we get that? Well, because remember the floating point number. So you got, so epsilon is the gap between, you know, 1 and the next machine number. Okay. So 1 plus epsilon is 1, and then dot 0, 0, 0. I mean, it's like the odometers, yeah. And then you turn on the last one, the last digits. Okay, so multiply by 2 to the 0. So remember the floating point numbers. So you have a significant and you have the exponent, yeah. And so now how many digits do we have in the double precision? How many digits? Well, maybe just forget about the number 1 here. So how many digits after the dot? How many digits after the dot? So how many digits after the dot? P, yeah, but what is P in our case? It's correct, but I mean, just how many digits? So then I can, yeah, 52, yeah, so 52 digits. So then epsilon, I mean, EPS here, it just, you know, when you expand this one in terms of binary, then it's just 1 over 2 to the 52. So when you put in Matlab 1 over 2 to the 52, then you got exactly this epsilon. Okay, so I can share with you. So suppose I share with you my Matlab. So you put in epsilon, you got 2.2 10 to the minus 16, and you put 1 over 2 to the 52. So you got the same number, okay?
Harvested honey.
Does 1 over 253 become 0? Good point. So let's try it. I mean, we can try it. So wait, I have to. So we can try to see what happens if I put in, say, 1 over. Oh, I don't get 0. I just got 0. Sorry, somebody forgot to mute. Okay, so I don't get 0. Okay, so I got like epsilon over 2. Okay, so epsilon is just the gap between, you know, 1 to the next machine number, yeah. But 1 over 252 does not become 0 yet, right? Why is that? Why is that? Well, because remember, you still have real mean, right? So real mean is much way smaller. Real mean, remember, so real mean is like you set everything equals 0, sorry, except the first digits, yeah, because it's a normalized number. And then you set the power to be E mean. Okay, so if something less than real mean, then yes, this becomes 0. But if something less than epsilon is not equal 0 yet. Okay, so does it make sense? So now if I take real mean, okay, and I divide it by, say, 100. Oh, so still not 0. But because it's a normalized number. Okay, so real mean is still a smallest but still normalized number. And Matlab is still storing unnormalized number as well. Yeah. And okay, so but now go back to the epsilon. Suppose what I say is 1 plus epsilon is the next digit after 1, right? So if I put 1 plus epsilon bigger than 1, then is it true or false? True, right? Because, you know, 1 plus epsilon definitely bigger than 1. But now if I put 1 plus epsilon over 2, is it going to be bigger than 1? True or false? Well, see, 1 plus epsilon over 2, right? you know, by calculus, it's still a positive number, so it's still bigger than 1, right? But if you enter, it gives you false. So why is that? Well, so in this case, then epsilon over 2, okay? When you add 1, it got rounded off, and 1 plus epsilon over 2 got rounded up to 1. And 1 cannot be bigger than 1, so that's why it's false. Okay, so that's why in the next lectures we will consider the rounding errors. So the rounding errors causing this illogical answer. Okay, because 1 plus epsilon over 2 is still something. 1 plus, well, I don't say that epsilon over 2 got rounded to 0, but I say that 1 plus epsilon over 2 got rounded to 1. Okay, so epsilon over 2 doesn't got automatically rounded to 0, but this one 1 plus epsilon just got rounded to 1. You see, so when you that's why, you see, I mean, there's some delicate procedures when two floating numbers are added inside a computer. Okay, so that is a good point. Okay, so what happened if I take 1 plus epsilon over, say, 10 to the minus 20, right? So I think it still got rounded to 1. No, I didn't write correctly. And no, when you divide it, it means that you multiply by a big number. Okay, so when you, what you mean? Do you want to divide or you want to multiply? Because if you divide, it means that you multiply with a big number. So this one become very big actually, because when you divide it by the small one, no, but you see, when you divide it by a very small one, that's become infinity. I mean, it's become very big. So epsilon, no. So in this case, no. In this case, when you add it up, so there's some rounding, but the rounding will be to the big number. Okay. So we were talking about rounding errors in the next lectures next week. Okay, but for the moment, I mean, 1 plus epsilon over 2 just got rounded to 1. Okay, because when you add a very small number. Yeah. Okay, so the next question is, suppose I get a big number. So I got 10 to the 200. Okay, so when we write 1e plus 200, actually it's 10 to the 200, and it's a big number. And then if I take exponent of x cubed, so what do I get? So what do I get? What do I get here? So 10 to the 200, right? So then you raise to the cube, so it means that 10 to the 600. Why 600 logarithm 10? No, it should be something bigger. Well, because remember 10 to the 200, the dot here just mean if a vector, then it take every element. Yes, it's infinity, right? Because, you know, I mean, if you take 10 to the 200, right? You raise to power 3, then you got 10 to the 600. Wow, it's the infinity already. Why is that? Because it's based on real max. So real max is this number. And remember, how do we get this number? So I explained it in the lectures already. But essentially, you know, I mean, the real max is, I can explain again. So real max is you turn on all the digits and you make the power to be E max. Yeah. So now suppose I have real max, yeah. So real max is so real max is this number. So you got 1 here. So maybe real max, real max, yeah. Is you got 1 at the beginning and everything is 1 1 1 1 to the last digits, right? And then you multiply with Emax, and remember in the double precision, Emax is just 1023, the maximum power you can get. Okay, and so this one, when you expand it into the values, this one just 1 plus 1/2 plus dot 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 plus 1/2 to the 52, right? And then you multiply by 2 to the 1023, yeah. Okay, so you see this one is the geometric series, and just 1 minus 2 to the minus 53. Okay, and then you divide it by 1 minus 1/2, right? And multiply by 2 to 1023. So this one just geometric series, yeah. And now this number is just, 1 minus 1/2 is 1/2. So you flip it, just become 2 minus 2 to the minus 52. And now everything is multiplied by 2 to 1023. Okay, so this one I will enter Matlab. Okay, so remember this number I put in into minus 2 to the minus 52 multiplied by 2 raised to the power 1023. And I get real max. You see, so real max, remember real max here is just for the double precision, and everything, if it's bigger than real max, then it's become infinity in Matlab. Okay, so if you take real max, you multiply by 10 and multiply by 100, you got infinity. Okay, so by ons what Matlab can do. Okay, so that is about real max. And the next one is, you have v equal minus 2 and stop at 2. So what does it do? So this one, it just start, it's a vector start from minus 2, right? And then it increased by 2, then it stop at 2. Okay, so then what do you get? What do you get for this? So you just got a vector minus 2, right? And then increase by 2, you got 0, then plus 2, then you got 2, right? So now what happened if I put like, v equal minus 2 increased by 2, but I stop at 3. So what is the answer? Is anyone else online Matlab not working? I don't know. I'm using my Matlab on. I'm using my Matlab on my laptop. So yes, so it should be the same, right? Because I mean, it cannot go to 4, right? Because 4, then it doesn't satisfy the condition less than 3. So it's just the same. Okay. So be careful about the limits. So it has to satisfy that still less than the limit. So now the question is ask you what is v divided by square root of v. Okay, so here, you know, you just have you know, I mean, v is minus 2, right? So if you take the square root of v element wise, yeah, so the first one give you minus 2i, sorry, minus square root, I mean square root of minus 2, right? So square root of minus 2 is just I times square root 2, and square root 2 roughly about 1.4142. Okay, and square root of 0 just 0, and square root of 2 is just about 1.4 something. And then when you take v dot divided by square root v, it just take element wise, take elements divided by each element. So here, so 0 over 0 is just not a number. V over square root v is equal square root v. It is correct if you don't have 0 over 0, yeah, here, because it is correct if you don't have a 0 case, but here we have a 0 over 0. So 0 over 0 give you not a number. Okay. Okay, so that's why we have to be careful when you have you know, 0 and you try to divide it by 0. Okay, so the next one is supposed to have x equal 0.1, and then h is 10 to the minus 18. Okay, so in Matlab, when you write 1e to the minus something, is 10 to the minus 15, yeah. And then now what is the answer? X plus h less than or equal x? Is it true or false? False or true? Well, so remember, in this case, h is a very small number, smaller than epsilon. Remember, epsilon is 2.2 10 to the minus 16. Yeah. So then x plus h, right, is got rounded to x. Yeah. So then x is still less than or equal x. So still 1. Yeah. So true. Okay. Well, I mean, in suppose, you know, I mean, this one in calculus, it has to be false, right? But because in Matlab, there's a limit in the, you know, how many digits you can handle in the floating point arithmetic. So that's why this is a consequence. When something less than epsilon, you know, put in, then it got rounded off. X plus h got rounded off to only x. Yeah. And you see, when you put h is bigger than this number, then it's no longer the case. Okay, so now the next question is about the singular case. So now suppose I have 1 over 0, then what do I get? No, 1 over 0 is not a number. No. Infinity, yes, because it's like a limit. When you take the bottom go to 0, then you just got infinity. Okay. And now what happened if you got minus 1 over 0? Minus infinity is correct, yes. How about logarithm 0? Well, logarithm 0 is still, because when you plot the logarithm, yeah, so you can plot I can plot it in Matlab as well. So suppose I plot it in Matlab, so you can see plot. So suppose I plot logarithm function, maybe 0 and 1 to say 5, and logarithm of 0 point, this one should be 0.01 5. Yeah. So if you plot the logarithm, you will see that no, that is not what I want. So logarithm of, okay. So where is my screen? So now let me show my screen. Yeah. So yeah, you can see the logarithm look like this. Okay. So when x go to 0, actually it's go to infinity. Yeah. So then logarithm of 0 should be, well, actually should go to minus infinity. Yeah. So logarithm of 0 should be minus infinity. Okay. So if you remember the logarithm of the logarithm of x is just a curve go to minus infinity. So now what about logarithm of minus 1? So what is logarithm of minus 1? Doesn't exist. Well, this one, if you haven't seen complex number, then okay. So let me give you the formula for a complex number logarithm. So a formula for a complex number is like this: logarithm of z is logarithm of absolute value of z, the modulus of z, yeah, where z is a complex number plus the argument time I of z. Okay. So now if you, so this is the formula for logarithm number. So if you consider minus 1, it's just a complex number, yeah, then logarithm of minus 1 is just logarithm of absolute value of, sorry. Yeah, so logarithm of minus 1 is just a logarithm of absolute value of minus 1, where it's just logarithm of 1, which is 0. Then the argument of minus 1 it just equal pi, right? Because when you draw the complex plane, yeah, then minus 1, the argument is just pi, yeah, and that's why the logarithm minus 1 give you here. So this one is the approximate value of pi, I, yeah. So I is the complex unit and multiply by the argument, yeah. So this one is only when you have seen the logarithm of a complex number. Okay, so now we saw 0 over 0 already. So in the previous case, yeah, so 0 over 0 is just not a number. Okay. And now the next question is, what is infinity minus infinity? Not a number, yes, because it's an indefinite form, yeah. And how about 0 times infinity? Not a number, it's correct, yes. And 0 time, not a number. Not a number, yeah. So now what about infinity over infinity? Not a number, yeah. So because infinity over infinity is indefinite. So now what happened if I take 1 over exponent of infinity? 0, yeah. Because you take 1 over infinity, it just equals 0, yeah. And now if I take 3, sorry, why 1 over 0 is infinity? Well, 1 over 0 is infinity is, you know, like you take the limit, you know, no, 1 over 0, yeah, is like when you take a limit 1 over x go to 0, that's become infinity. So in this case, you know, Matlab just has some special rules. So if you have 1 over 0, just make it to be infinity, okay? And the rule should be consistent with calculus, because calculus was invented long before Matlab, okay? And people still use calculus. Okay, so why 1 over exponent infinity equals 0? Well, because exponent of infinity is infinity, right? Yeah. And so 1 over infinity, it just equals 0. Okay. So it's consistent with calculus. Yeah. So exponent of infinity is infinity. So 1 over exponent of infinity just equals 0. Yeah. Is that okay now? Okay. So now what happens if I have 3 infinity minus infinity? Yeah, still not a number because indefinite form. Yeah. And then if you have 3 infinity plus infinity, and you got infinity, yeah, because infinity plus infinity is still infinity. And then not a number minus not a number, not a number, right? So still indefinite, yeah. And so now the next question is, what is the following of the following command? What is the following what is the output of the following command? So if you got 4 minus 2 minus 3, I mean 4 colons minus 2 minus 3, and what did you get? Yes, because 4 you decrease by 2, then you got 2, you decrease by 2, you got 0, you decrease by 2, you got minus 2, and you cannot go further, right? Because there's a minus 3 here. It prevents you to go down to minus 4. Okay. And now if I have 1, 4 prime, so what is just column vectors from 1 to 4? Yeah. Yes, but now I want to multiply with a matrix 1 by 3. Well, actually it's a row vectors, only contains number 1. Then what do I get? So a columns vector, why doesn't compute? So column vectors multiply by row vectors. Yeah. So this one is well, I have to remind you about the algebra. So this one is good to try to remember the algebra. So the linear algebra. Yeah. So now if I have, how you make a column vectors with a prime script? No, you are correct that if everything is between the two quotes, then it's a string. Okay, but if only a single quote, then it's a transpose. Okay, you can try it. Okay, but now, let me. I will go back to that. 4 by 3. No, it's a 4 by 3 matrix. Yeah. So yeah. So okay. So now you got 1, 2, 3, 4 like this. Okay. And then I just remind you a little bit about linear algebra, and you got 1, 1, 1 like this. Okay. So it will be a 4 by 3 matrix. Yeah. So it will be 1, 2, 3, 4. So just refresh how you do the matrix multiplication from your memory. Okay. So you got 3 columns identical, 1, 2, 3, 4. And Matlab has to be consistent with linear algebra. Okay. So the 4 by 3 matrix. So now if I go back to Matlab and I hit the button enter, then I should get this matrix. Okay. And so actually we have to be a bit careful about this prime operator. So if you have 1 to 4, when you take prime, that will give you a column vectors, yeah, from 1 to 4. But when you have something like 1 plus I, okay, when you take prime, then what happened? Why? No, we have to clear the variable I. Why we have I equal to 200? Okay, so 1 plus I, yeah. When you take the prime, but actually it compute it compute the transpose and the conjugate. Okay. Yeah, I just clear I already. So that's why we have to be careful. But you see the vector is 1 plus I. Okay. But when you take a prime, it makes it a column vectors, but it also conjugate the complex number. Okay, so be careful if you use the prime operators here. So the prime here, take the conjugate and transpose of a vector or a matrix. So be careful. For a real matrix, real vectors, no problem. But for complex values, then we have to be a bit careful. Okay. So now we go to the next question. So about lin space. So lin space. So this command is, like one. So take the interval 0 to 10, and it divided, okay, into 4 equal spaces, 4 equally spaced. So that got 5 points. Yeah. So remember the 5 here is 5 elements. So you got 1, 2, 3, 4, 5. Yeah. So you take the interval from 0 to 10, you divide it into 4 pieces. Okay. And then you got 5 elements. So 0 and the 2.5 and 5, 7.5 and 10. So equivalently, you can do the same by start from 0, right? And then you increase by 2.5, right? And you stop at 10. So that gives you the same answer. Okay, but sometimes you're a bit like you don't bother, like what is the increments, you just want to divide it into equally spaced. But remember, the number of intervals is 1 less than the number of elements. Yeah. Okay, so the next one is about how you modify the matrix in Matlab. Yeah, so suppose I have I3. So it means that this is a identity matrix, 3 by 3 identity matrix. Okay. And I is for identity. And suppose you put in a row vectors 2 to 4. Yeah. And then you put in column vectors 3 to 6. Okay. So now if I want the vector u, I mean the row vector used to be a new row of a matrix A, then I just put a semicolon and then I put the vector u in, and then I have a new matrix A. That's very easy to edit a matrix in Matlab. So you see the matrix A initially is an identity, and now you have a new row. So 2, 3, 4. Okay. And now suppose I want to put a new columns. Then I got the matrix. I put a column next to that. Okay. So very, very easy. Yeah. So matrix manipulation in Matlab is very easy and very intuitive. So the next one is about setting up a matrix by using commands. So now maybe let me do it by hand first, and then you see what is going on, and then I will show you the commands. Yeah. So suppose I set it up by hand. So I suppose that you have the question in front of you. So now suppose I erase this. Very clear. Yeah. Okay, so now suppose I have a matrix. Yeah. So if you look into the question, yeah, the matrix C. Okay, so you have a matrix C is a 2 by 3 matrix, and all of them are 1. So this is a matrix C, look like this. Okay, so this is the command that gives you the matrix C, and then you have a matrix D. What is twice the matrix C? So you got two here. Okay, so this one's simple, right? But now the matrix E will be a bit complicated. So how do I construct the matrix E? So the matrix E, so if you look at the question, it will be a bit complicated, but let's see. So you start with a matrix C, okay? So I put in a matrix C, yeah? So 1, 1, 1, 1, 1, 1, yeah? Then if you look at the next command, okay? It say that, so if you look at the question, you will see that it takes the matrix D, but it doesn't take the full matrix D. It takes only a subset of a matrix, sub-matrix D, yeah? The sub-matrix of a matrix D. And the sub-matrix is defined by row 1, row 2, and column 1, column 2. So only this part of the matrix D got input into the matrix E. So you got 2, 2, 2, and 2. Okay, so if you follow or maybe let me put the commands in the chat box and you can follow it. So C, D, 1, 2, 1, 2, 1, 2, 5, 4, 1, 4. Okay, so the matrix E is defined like this. Yeah, so you can see in the chat box. Yeah, so this is a matrix E. So I just explained to you how to construct bit by bit of the matrix E. And you see that I got the matrix C in, then I got a sub matrix of a matrix D in. Yeah. And now after that, you see there's a semicolon. So semicolon is mean that you have to put in new rows. And what is the new row? So the new rows is actually a 2 by 5 matrix. Okay, so two rows, 5 columns matrix, and every elements are 3. Yeah, so then you got 3 here, so 3 here, 3 here, 3 here, so 3 here, 3 here, 3 here, 3 here, 3 here, 3 here. Okay, so it's not over. Now you put something, you know, in the next columns. Yeah, so the next column say that you put in a 4 by 1 matrix, which is just a vector or column vectors. Yeah, four elements, column vectors, and all of the entries are just 4. So you got a matrix E. You just add on a column like this. Okay, so finally this is your matrix E. And now see whether Matlab do output the Matlab will output the same thing. So now let me cut and paste this command into Matlab. Well, we have to define C to be 1, 2, 3, and D equal to times C, okay? And then now you just cut and paste this command into Matlab. I see. So you see exactly what we've got. So we did it by hand, and then we compare with output by Matlab, and you can see that the results are the same. So you see what is going on. So Matlab is very flexible with manipulating matrices. Yeah. And now the next one is just you extract a subset of a matrix E, a submatrix of a matrix E. So F is E, right? And you take only row 2, row 3. Okay, so row 2, row 3. And then you take columns only 3 to 6. So you see that row 2, row 3. So row 2, row 3 is only this one. Yeah. But you don't take the full one, but you take only from column 3 to 6. So column 3, yeah, 4, 5, 6. So you got 1, 2, 2, 4, then 3, 3, 3, 4, and you will see that. Oh no, we have to give some. Oh, no, yeah, it's correct. I think I enter this one incorrect. I didn't enter the correct command. So here. You don't see my Matlab screen, sorry. What did you see? You have to tell me, sorry about that. Yeah. So you see that is the matrix, the matrix E. Yeah. So we just put it in here, and the matrix E, yeah, is you know, just take a row 2, 3, and then column 3, 6. Okay. So you take row 2, 3, column 3 to 6. You got only this 1, 2, 2, 4, 3, 3, 3, 4. Okay. Okay. So the next question is you compare. Okay. So we talked about this one before. Yeah. So we compare X obtained by this construction. So start from 0, increase by 0.2, and stop at 1. And you know you got 0, 0.2, 0.4, 0.6, 0.8, and 1. Right? So increase by 0.2. But if I put lin space, okay, 0 to 1, then how many elements I should put here? So if I put 5, okay, then it divided into 4 equal space. Right? So I got 4 elements. I start from 0, then 0 0.25, 0 0.05, 0 0.75, and 1. Okay. So okay, so now the next question is maybe this one. Let me share the screen. So the next question is the difference between the script and the function. Okay, so how you see, suppose you have an ellipse and you want to find the area of the ellipse. Yeah. Then how do you run the script and how do you run a function? So how do you run a script? So anyone, have you tried this one? Well, to run a script, you just type in area 1. Yeah. Okay, so anyone have tried this one? So if you, so nobody have tried this one, so suppose I type it in. Yeah, so suppose I type this one in. Yeah, so I just cut and paste into my Matlab. Yeah, so now, yes, you just type the file name. Yes, so suppose I make a new script, so new script here, and I just cut and paste here. Yeah, and then you have to save, or you can run it here, but it asks you to save. So area 1. Okay, so you run it. So area 1 is say for 6. Then you see S is the results. Okay, and now suppose you have a function. Yeah, so now suppose you have a function. So now I say new function. Yeah, then let me cut and paste the function here. Okay, so so how do you run the function? So you have to save it first. Yeah, so area 2. So how do you run a function? So how do you run a function in Matlab? But you cannot type area 2, because if you type in area 2, it will say something. You don't have input arguments. So how do you run a function? Well, you have to enter, yeah, you have to enter the input arguments. Yeah, so 2, 4, yeah, or 4, 6, whatever. Yeah, so then you get the same answer. Okay, so the next question is, how do you define a real number in Matlab? So 0.15 multiplied by 1e minus 8. Okay, so this one just give you the number. And then how do you define a column vectors? So x equal 3, 5, 7, 9, 11, 13, 15. So how do you define that? So how do you define the vector? Well, you can write out like this. Yeah, but I think this is a long way. Yeah. Yes, so you have to start with 3, increase by 2, stop at 15, and then take a transpose. Okay, then it's a very fast way to define the column vectors. And now, how do you use Matlab to solve the linear system? Okay, so this one is A is, you define matrix A 2, 3, 1, and 4, 7 minus 8, and then 0, 1, 3. Okay, so this is your matrix, and then you define the right hand side. So the right hand side is B is 7, 5, 1, and there's a backslash command. So you just take a backslash B, then you solve the linear system. Okay, so this one, it just solve the linear system AX equal B by Gaussian elimination. Okay, so that is how you solve the linear system in Matlab. And the next question is another useful command. So suppose you want to make row vectors to be a column vectors. Yeah. So there is another way you can do like this. You don't have to transpose, but you do a open parenthesis and colon, and then it will produce a column vectors for you. But you see this one, if we take in a column vectors, then it produces a column vectors always. Yeah. So this is operators. And then I have to stop here because I have another class right after this, and I have to run across campus. So can we stop here? Yeah. So any question? So there's the next two question, how to plot a circle. So please try to plot a circle using a parametric equation of the circle. Okay. So maybe I can do it real fast. So you can do like this. So something like t equal lin space, 0 by 1,000 points, and you define x to be a, well, a is the radius. Yeah. So a is say 5 cosine t, and y equals sine 8 sine t, and then you just plot xy, and this one plot a circle for you. Okay. So this one is plot circle. So I say, and you can run it, and you can see you get a circle. Okay. So can we stop here, because I have to run across campus. Yeah. So I stop. Okay. So see you next week. Have a good weekend. Yeah. So stop recording.